Here is my solution for homework 5, which is due class 6. This is problem 1. We have cables that are suspending this light fixture at a U-Hart Lincoln Theater. And the tension in cable AD, this one right here, is 225 pounds. The dimensions are 40 inches, 35 inches, let's see, YAB, this is 60 inches right here, this is 36, and this is 32, and we want to find the weight of the light fixture. And some real thing might happen here. Maybe we have in this cable AD, maybe we have something that's able to tell us what that tension is. So that's a means that this almost can be sort of like a scale to try to weigh what this fixture is. Okay, so do I have my camera on? No, I think I turned it off. There's the camera on. Boom. Okay. Now I drew the thing out already. Let me take a look at the problem over here. I drew the problem out. Didn't do the greatest job of getting it to fit in there, but I figured I'd make the video shorter maybe by doing this. Okay, so in a given for this things they told us that the force in AD, the tension, let's see, it's just the magnitude of that, is 225 pounds. I was told that XAB is 40 inches, XAD is 35 inches. That was that one right there. YAB 60 inches, 5 feet. ZAC is going to be 36 inches, and ZAD is 32 inches. Okay, and we want to find W. So this is W right there. Okay, so move that so it's more nicer angle. Let's start out with an FBD, which honestly, with the three-dimensional one, isn't always that all that exciting here. But we'll put it in here, try to represent it. So we have this weight is coming down there. We're going to have a force there, and a force there, and then a force there, right? So we say F, and then we call this AC, and this is force AD, and then this is force AB. And we say the sum of the forces is equal to 0 as a vector. So FAB plus FAD plus FAC plus W is equal to 0. We do know we can write out what this is going to be. It's just going to be the weight negative the weight times J right there, right? And that's going to be pounds, but we're leaving it as a variable right now, so I don't necessarily have to give it a thing. But we know we're going to get a magnitude down, and that's the thing that we want to try to find eventually. All right. So what we do is we have to start getting our direction cosines as part of this. And I'm going to make this a little bigger so I can get some of this up here in there. Let's start out in alphabetical. Let's start out with AB right there. So I find that the direction cosine is going to be B with respect to A. And can I do this in my head? I think I can. I don't necessarily have to. Sometimes I'll go step by step on this, and each of the this minus this minus this. But I think I'm given all the dimensions, so I don't have to have like B minus A, XB minus XA to be able to get what this is going to be. But if I had to, I could do it. So anyway, in the X direction, let's see. B is going, let's see, X is this way right here. B is actually going in the negative XAB right there, negative XAB. So it's going to be a negative 40. and then in the y direction, it's going to be upwards by YAB. All right, so 60 inches. And then in the z direction, let's see, there should be, I think it actually lands on the same thing, right? So yes, okay, so this lands on where it connects. All right, so if looking at the original problem, so you don't have to interpret right through here, you could see that this is coming straight up, and then this is going to be 0, right? Because it's on. So this cable is on the same z location as A. So that's 0. Okay, and that could sometimes help us, by the way, to make things just like a little easier. And these are all inches. And while we're here, let's figure out what this is, and I can try to cram everything in there. I'm going to leave off the minus sign. I can actually make that shorter, and I don't have to cram. Use the handy dandy Hewlett Packard calculator. Maybe I'll convert one of you one of these days to see how many few strokes I took right there. Maybe you don't. You're not going to be convinced. 72.11 inches. Okay. So if I'm going to have my direction cosine thing, I'm just going to call that AB, and that's going to be negative 40 divided by 72.11 I, and 60 divided by 72.11 J, and then I don't need to write out the rest, just 0K, but I'll put it in there. So here's my direction cosine. The trick here is I can go enter, enter, so it goes into 2 places right there. I go 40, I divide, and I take the inverse of it, so that's another trick. Whoop, gotta make sure that's negative though. 0.5547 I, and then I'm gonna flip these right there, and then I'll do the same thing here where I have 60, and divide, flip, and I get 0.8321 J. And that has no units, and so that I know when I get the vector AB is going to be F AB times lambda AB. So that makes it into a vector where we have that tension. Now let's go for AC. Our C with respect to A, right? So we're going to go over into that direction. And in the X direction, it appears we're going to move, in X direction, once again, it lands on the same as this right here. So you see that it's right in there. So this C has the same X as there. These things will make solving this thing just a little easier. It's still going the 60 inches upwards, right? And then in the Z direction, we're going to have negative, right? Because it's coming away from this thing, and it's going to be that AC. So it's going to be negative 36. Okay, and these are inches. So we can take our C with respect to A, get the magnitude of that. It's going to be 60 squared plus my 36 squared, or 60 squared, 36 squared, and we have 69.97 inches. So we take our lambda AC, and that's going to be, 0I, okay? And then 60 over 69.97 J plus our negative 36 over our 69.97, and that's, that's supposed to be a K. Forgot my K in there. Okay. Such a dad. Okay, enter, enter, enter. 60 divide, boom. So we're going to have our 0I plus our 0.8575, 575, yeah, okay, J, and then our negative, don't forget it's negative, and flip those around to take my 36, divide inverse negative 0.5145, K. I think they got in there, right? And then remembering that FAC is going to be equal to the magnitude of the tension times the position vector right in there. And then lastly, we have AD, and we actually have the value for AD, so we can actually come up with numbers as part of this. So we have RD with respect to A, and it's going to be equal to, let's take a look. Well, it looks like we are going this direction here, so we're going to go, and that's positive, so this is ahead of the thing, so it's going to be 35 inches. I didn't draw it to scale. Y is still 60. And in the Z up here, looks like it's positive, right? So it's because it's going that a ways in the Z. It's going by ZAD 32. So if we, so this one actually has, whereas the others had one of them was 0. This one I have to squeeze in there. 35 squared plus 60 squared plus 32 squared. Explant looks kind of bad. So 35 squared, 60 squared atom, 32 squared atom, take the square root, and we get 76.48 inches. And my keyboard won't let me slide my papers up from here, so I'll move the keyboard over there a little bit. And we will find our direction cosine, AD, let's call it, is going to be 35 divided by, none of those are negative, are they? Okay, good. Double check it. 76.48 I, 60 divided by 76.48 J, and 32 divided by 76.48 K. And actually, we could probably written this out a little different. That's okay. I'll take it back. So let's see here. We go 35. Whoa. Let me go down. We'll go enter. And 35 divided 1 over. I get 0.4576 I. Flip them around, and 60 over 0.7845 J, and then the last one. And here I can use this thing and I go down the stack here. All right, so I've rolled down the stack. The stack is 4 long, so I have this again, my 76.48, and I'll take my 32, divide, come back over there, and I get my 0.418. Didn't make that look like enough like a 4. I'll go back and fix it. 4 K. Looks almost like too much like a 9. I'll write the whole thing out again. 4184. 4184. I don't know if I made that any better. Okay. Now what I can do is write out my force. FAD is going to be equal to the FAD magnitude times the gamma AD but I know this FAD, right? It was given as 225. So I write 225 times my 0.4576 I plus my 225 times 0.7845 J plus my 225.4184 K, and that's going to be pounds. And I'm going to write out here, running out of paper there, so we'll go to the next one. And what we could do in our stack here is we can roll this down, and I have that's still in my memory right in there. So I just go to 225 and multiply it by there, and I get my 103.0 I. And let's see, can I still use this? Let's see, let's see, I can roll that down right there. Okay, so I have the 0.7845, it's still in there, and multiply by the 225. 176.5 J, and then I still have in here somewhere, like right there, 0.14 right there. So I can go 225, boom, and I get a 94.14 K pounds. That's like this little tricks that are you make it useful, that stack right in there. All right, continuing on. I have everything I need. So now I'm going to plug all of those into here, but keep the I's, J's, and K's separate, right? So I'll rewrite this thing out. Let's see, this is going to be page 2, Dr. Deal. Spring of 21, this is ES110, homework 5. And this is problem 1 continued. So let's rewrite. I'll write out this is the thing we're sticking it into. FAB plus FAD plus FAC. Why did I go that way right there? Why didn't I go AC and then AD? That would have been right. Would have made more sense, wouldn't it? Plus W equals 0. So this is going to be a pretty long one right here. So let's see. Here's going to be the I's. I'm going to have for AB right here. So let's move this guy up here. For AB, I'm going to have FAB times negative 0.5547. For AC plus FAC, there's nothing, right? Because there's 0. I can even just leave that out for the I. For the AD, I have it as, for FAD, I know this to be 103.0, right? And then for W, don't have anything, right? Don't have anything in the I direction. Everything's in the J direction. So I'm going to be able to solve for FAB right away. That's going to be nice. But we'll continue on with writing this thing out. All right, so let's start out with in the J direction here. We have FAB, which we just did an aha moment, said we're going to be able to find that from the I, so we're golden there. It's going to be multiplied, the FAB is going to be multiplied by a positive 0.8321 right there, right? In the J direction here, we have plus FAC 0.8575. All right, and now for FAD, we actually have a number right here, right? I'm going to have to go down to the next line for the next thing, though. And then lastly, for W, we have a negative W. Okay, right? So we don't know. So I'm going to continue over here. It's too bad I couldn't keep it within the same line right over there, but that's okay. All right, so that right there is an equation right here, and that needs to equal 0. That's probably going to be the last one we do. We think we could kind of plot, we could kind of see that at this point, that we know this, but we don't know that, we don't know that. So let's see what happens over in this last one right here for in the K right here. All right, so first off, we have 0K, that's fine, for the FAB, so we don't need to do anything for that. For the FAC right here, we have, for K, we have a negative, so we have FAC and a negative 0.5145. And then for the FAD, we have a plus 94.14. And then for W, there's nothing right here. So actually right here, we're going to be able to solve for this one too. So I think we can see, hopefully here, what our path forward is. Each one of these has to be equal to 0. So in the I direction here, we see that FAB is going to be equal to 103.0 divided by 0.5547. If I have in my stack right here, I have that value right here, so 0.5547 divided. So I have 185.6 pounds. I'm going to skip the J because I recognize that I still need FAC that I can get from here, and I'll go to K. And solving for here, I'm going to find that FAC is going to be equal to 94.14 divided by 0.5145. That is located right there. So I'm going to flip those over because I want to try to keep that other one up there because I might need be useful to there. Well, I need that 0.5145 divided. So I have 183.0. And then lastly, I go to J and plug this in right here, and I go ahead and put the numbers in here. We have 185.6 times 0.8321 plus FAC of 183 and 0.8575. And then, whoops, what happened here? Come on, please come back. Please come back. Huh? No? There you go. I think this had gone on long enough that I had my computer decided it was going to go into sleep mode or something. 176.5. And then we have minus, is it going to be equal? It could be, I could write minus W equals 0. We know that. So the weight of this thing, okay, so I plug these in here. I have 183 right here, so I go 0.8575 and hit multiply, boom. And now I need this 85, so I can flop them over and go 0.8321 times right there. So that's what and now I can add those together. And then you can also see that still in my stack is the 176, so I hit plus. And there is my answer, 487.9 pounds. And I think I can actually even just go ahead and say here is my answer, because boom, I don't have to rewrite it again. 4 sig figs, box it, good to go. And voila. Let's see how long this took. That is a 25-minute problem. These are hard problems, and they are time-consuming. So hopefully it doesn't take you too much longer than that. I did do a lot of talking while I did there, but of course I kind of knew where I was going along the way. I've done these before, so hopefully it won't take you more than twice as long.